All right, it's time to go on to our next lesson, which is week 2, lesson number 2. Let's find out all about it. Before we start, I just want to remind you that office hours are Mondays from 7 o'clock to 9 o'clock. You do need to email me ahead of time so that I can expect the visit and include in the email what topics are giving you a hard time so I can prepare to help you as best as possible. As far as today's lesson goes, we'll go over the homework. We will review some questions, some praxis type of questions and so on from the last couple lessons. We will encounter the do it for today, which will reinforce everything. We'll do an announcements page, and we're going to continue to talk about what is an algebra and some more truth with operations as a whole, not only addition and subtraction, but multiplication and division. So we are just going to carry on. Here's your homework answers. You can take a look at it, make sure you understand how to do it. If you have any questions and you can't talk to a classmate or understand from the work that I am showing you, then please reach out in an email or in a contact. And by the way, listen, I make sloppy mistakes frequently. I just seem to. I have a gift for it. So there are probably going to be times where I get a homework question wrong because of a sloppy mistake, and then you can send me an email. Or who knows, maybe I'll get a homework question wrong on purpose, and I want to see emails that say, hey, Mr. Lindquist, did you realize? And then I can go from there. All right, check your answers out. All right, so I assume at this point in time that you have paused the video, if not, do so now, and you've gone through the answers. Now let's do some praxis power. Performance is a function of preparation. And what we want to do is we want to prepare to do well on the praxis. So let's hit a few questions. Okay, give this a try. Which set of integers could represent the lengths of the sides of an isosceles triangle? Recall that an isosceles triangle has 2 equal sides. Go ahead. And you did stop and start. There's your triangle. If you try all of the combinations, the one that will work is choice 2, 5, 5, and 9. 4 plus 4 only equals 8, so that won't work. It's got to be greater than 8. 4, 7, and 8 do work, but it's not an isosceles triangle. That's the problem on choice 3. Right? It had to be also, not only did it need to be able to make a triangle, but it needed to be an isosceles one. And number 8, sure, it would be theoretically isosceles because of the 2 8s, but they add up to 16, and that's not greater than 19. Okay, let's find a pair of inscribed angles. Go ahead. Stopping and starting, of course. All right, so angle B in the first diagram is half of 140, which makes 70. And in the second diagram, it's half of 148, which makes 74. Match the property. Go ahead. I did rearrange them from the other day, so let's see you do the matching. Of course, do stop and start. Remember, the key to understanding properties is to remember, what does the word commute mean? To switch. What does the word associate mean? To be grouped with. What does the word distribute mean? To give out. So understanding those English language words and then using that to recall what the property says is super helpful and will guide your matching. Go ahead. Okay, so first, that's the commutative property of, it's not of addition, it's of multiplication. What the heck? That's supposed to be the commutative property of multiplication, choice D. I do not know why that arrow went there. See, here's a silly mistake on my part. So number 1 should be choice D. Oh, no, I'm sorry. Number 1 should be choice B. B as in Bobby. The commutative property of multiplication. It's commutative because it switches 8338, and of multiplication because it is times. I do not know why that answer was given. I don't know why it's going in this order, but number 4 is the distributive property. Clearly, you're giving out the 5 to the A and the C. I apparently reversed the commutative property of addition and multiplication because choice 3 should be the commutative property of addition. A. Number 3 should be choice A. Number 2 is correct. Choice E, the associative property of addition. And number 5 is correct. That's the associative property of multiplication. See how the A is switching who it's being grouped with? And number 6, that is the commutative property of addition. And that is correct because the 4 plus 9 in parentheses are staying the same. They're not changing, okay? What we're doing is changing the order. One says plus 7, the other says 7 plus. Okay, so just remember to follow the marks verbally, that some of these red arrows are wrong. Namely, for number 1, again, should be choice B, and number 3 should be choice A. Distributing reps. Reps are repetitions, and repetitions are very helpful in making you good at whatever it is you're doing, be it sports or math. So let's see you try all of these distributing problems. The first one's a single distribute. The next 2 are double distributes. Give it a shot, and we'll go over the answers. You guys do. Stop and start. Okay, so the first one, we distribute the 7 to all 3 terms. 7 times 3a is 21a. 7 times negative 4b is negative 28b. And 7 times 5c is 35c. Okay? When we get, and remember, you can't combine those. Those are all different things. A's, B's, and C's are all different. Next, distributing the x. X times x is x squared. X times negative 11 is negative 11x. Negative 7 times x is negative 7x. Negative 7 times negative 11 is positive 77. Now, in these double distributes, you will typically be able to combine the middle terms because they'll be the same category or the same kind of thing. So negative 11x's and negative 7x's combine to make negative 18x's. You can't combine the x squared with the x's with the 77 because those are all different types of things. All right. Now, let's take a look at the third one to do. 3x times 4x is 12x squared. I don't know why I wrote 3x squared. I must have thought it was just a 1 there. So 3x times 4x should be 12x squared. Once again, it should be 12x squared. 3x times 3 is 9x. Negative 5 times 4x is negative 20x. Negative 5 times 3 is negative 15. So the one mistake is 3x squared should be 12x squared. So it should be 12x squared minus 11x minus 15, because 9x's and negative 20x's make negative 11x. So just again, keep in mind, 3x times 4x is 12x squared, not 3x squared. Okay, a little lesson review here. Now, we've done this. This will be the 4th time that we've done at least the 4th time, probably more like the 5th or 6th time that we've done a sheet like this. So you should be pretty confident in this. If for some reason you're still getting one of these questions wrong, then I think you should have asked me or a friend in the class how to do it. Or a friend that might have taken the course, well, this is the first time the course is offered, might have taken this material in another course. Okay, stop and start. Go ahead. Okay, so for the first question, I'm converting 1011 from binary to base 10. You can see my work here. 5a of the hexadecimal base 16 to base 10. You can see the work there. Find the sum of the following binary numbers. There's your work. Find the product in base 7. That just means divide by 7 at the end. Find the remainder. So the first one, 5 times 3 is 15 divided by 7, has a remainder of 1. And the next one, letter B, has a remainder of 2. To subtract here, the big thing about subtracting is when you borrow, you'll be borrowing 8 at a time. So even though it says a 1 up here, it's really 8, and 8 and 3 make 11. 11 minus 4 is 7. 7 is a number in base 8, and then 2 minus 1 is 1. Okay, I'm just pausing it for a second longer so you can stop your screen if you want. And just look at these explanations. If it gives you a hard time at all, please reach out. Okay, so some announcements. There's no assessment this first week. Assessments will start next week. The first project will start next week. Let's see. It's not enough to just do your homework. You must learn from it. That's the point behind homework. I talked about going to the doctor, getting diagnosed, and then taking medicine for whatever the problem is. If you don't take the medicine, the problem just lingers, okay? So this involves not just doing the homeworks, but grading it and determining where you might have gone wrong and how to correct that. If necessary, watch the section of the video that's giving you a hard time more than once. That way you can look at it 2, 3, 4 times and it can make more sense to you. And always make sure you're checking Moodle frequently for assignments, updates, and adjustments. I will email you when I sense that there's something you need a reminder or there's something wrong with work that I did. Seeking eternal truths about addition. This is review now, but this is a really important concept to wrap your head around. What's 3 puppy dogs and 2 puppy dogs? Well, that would be 5 puppy dogs. 3 kitty cats and 2 kitty cats, 5 kitty cats. 3 puppy dogs and 2 kitty cats? Wow! It's a problem. It's a fight between animals. 5, huh? Got to get a common category. Remember, we spoke about how you could say 5 pets, 5 mammals, 5 furry little creatures. You must get a common category. Now, that doesn't only apply to puppy dogs and kittens. It also applies to fractions. In this case, we wrote those fractions as words. Okay? Try all 3 of these, then we'll give you the answers. Okay. 3/5 plus 1/5 is 4/5. 2/9 plus 3/9 is 5/9. A 9ths, 5ths, puppy dogs. It is what it is. I don't care. 3 of something plus 1 of something, like in example 1 here, is 4 of that thing. In this problem, it's 5ths. Okay, great. In problem 2, it's 9ths. Great. I get it. Right? If I add 2 of anything plus 3 of anything, I get 5 of those things. But I can't add things if they're different, which was number 3. What's 1/3 plus 1/5? We got a problem. Need a common category. Now, in mathematicians, because they're brilliant and lazy, they give you shorthand. What's the shorthand? They write fifths this way underneath the top one. So 3/5 plus 1/5 is 4/5. But it's the same exact logic as puppy dogs and kittens or currency. More shorthand. 3/8 plus 1/8 is 4/8. Now, here's the thing. 4/8 your calculator will reduce for you to 1/2. You are a college student now. I am not going to give you test questions that ask you to add and subtract fractions. That's just not going to happen. However, I will ask you to write out and explain things about the process that you're using, why you're using it, and how it compares to other operations with things, okay? So in that particular case, if you're not good at reducing fractions, like you could see, I would hope by now that everybody could say, well, I got 3 things called eighths plus 1 more thing called an eighth. I have 4 of those things called eighths, so it's 4/8. What you might not realize is that you should reduce 4/8 to 1/2. And if you do this concurrently on a graphing calculator, it will reduce the 4/8 to 1/2 for you. Fun with fractions. I like fractions. Most people don't think it's possible to have fun with fractions. Try those too. Go ahead. Stop and start time, guys, right? Okay. 7/9 minus 4/9 is 3/9, and on that calculator, you do 3/9, and all you do is to put a fraction into a graphing calculator, you hit the alpha button and the y equals. You'll see 4 options come up. Choose the one that fits what you have, which is probably the first option. And then you just type in 3/9, hit enter, and it'll tell you 1/3. Now, for 4/5 minus 1/3, this is where we have a problem, because we don't have the same type of thing, right? On the first question, we had the same type of thing. They were both ninths. If you want, picture 7 and then the word ninths written next to it, minus 4 and the word ninths written next to the 4. 4/5 minus 1/3, not such an easy grind. Now we need the common denominator, and we did start talking about this in the last lesson. 2 things. First, if you realize how to get a least common denominator and you're good at it already, you know it's the least common multiple of the denominators, and you just figure it out, great. But a lot of students stumble with that. If you're one of those students who do stumble, what you can realize is if you take the denominator of the second fraction and multiply the top fraction by that denominator number, which is 3, and always write it as a 1, 3/3. And then for the bottom one, you use the top denominator, 5/5. If you do that, you will always, anything unclear about that? Always get a common denominator. So 4/5 times 3/3 is 12/15. 1/3 times 5/5 is 5/15. 12/15 and 5/15 make 17. Oh, we're subtracting here, sorry. 7/15. 7/15 is the correct answer. Okay, your turn. Remember, stop and start. Okay, so for this first problem, it's they did the second problem first. Okay, 4/7 minus 1/3. Again, use the 3/3 for the top fraction, the 7/7 for the bottom fraction. I get 12/21 minus 7/21, which is 5/21. For the first problem, 7/18 plus 4/9. Now, in this case, if you recognize that 18ths are ninths, because 9 times 2 is 18, the least common multiple of 9 and 18 is 18, then you just stick with it as 18. If not, then you can get another common denominator, which would be, in this case, 36, okay? Or maybe even bigger. Yeah, it would be even bigger. But at the end, you would be able to reduce it. Okay, 36 is a common denominator. But in this case, you would get 9 times 18, which is 152. And that would be the denominator you would choose if you did the technique like in the previous problem where we put the 3/3 and the 7/7. Okay? So recognizing that 18 is the least common denominator here, making it a little cleaner so we don't have to reduce it at the end. 7/18 times 1/1 is 7/18. 4/9 times 2/2 is 8/18. 7/18 plus 8/18 is 15/18. And if you do the alpha y equals fraction button in your calculator, that will tell you 5/6. Okay, now we got 2 more, one of which involves mixed numbers. Okay, so 7/8 minus a half. Again, you could do, again, they start on the right-hand side. Okay, so 3 4/7 plus 5 1/3. Get that common denominator of 3/3 here in the top one, 7/7 on the bottom. That gives me 3 12/21, right? 4 times 3 is 12. And 5 7/21. 1 times 7 is 7. Adding them up, I get 8 19/21. So you just add the whole number parts, 3 and 5, and then you add the fraction parts. For the next one, remember how before I said I hope you recognize that 8 is the least common, or in the other one 18 is the least common denominator? Well, let's say in this one you don't recognize that it's 8. This is a good example of how it would have reduced in the previous problem in case you did not understand. So I don't think about what my least common multiple of the denominators is. I just say, look, I know the system that works here. The system that works is I put a 2 and 2, and then I put an 8 and 8. So 7 times 2 is 14, 8 times 2 is 16, 1 times 8 is 8, 2 times 8 is 16. I add them up and I get, or I subtract in this case, sorry, and I get 6/16, and that reduces to 3/8. Had you recognized that 8 was the least common denominator, you would have arrived directly at the reduced answer of 3/8. All right, give this one a try. Okay, so 3 3/4 minus 1 1/3. 3 3/4 would become, first we get the common denominator, which I use the trick here, or the strategy, of 3/3, and then 4/4, if you did not recognize that it's 12ths. So 3/4 times 3/3 is 9/12. 1/3 times 4/4 is 4/12. I'm subtracting here. 3 minus 1 is 2, and 5/12. Okay, now just a little reminder about key things with subtraction. Okay. What is 7 puppy dogs minus 2 puppy dogs? 5 puppy dogs. 7 kitty cats minus 2 kitty cats is 5 kitty cats. 7 puppy dogs minus 2 kitty cats, 5 pets, 5 furry creatures. I get a common category in which to group them. Now, I just do want to emphasize to you that subtraction is nothing more than adding the inverse. That's what the math textbook would tell us. And because subtraction is just addition of the inverse, then it should follow operating the same way we do with addition. And that's why you have to get a common category for subtraction as well. All right, so 2 combining like terms problems. Go ahead. Okay, I'm sure that you did stop and start and you're used to that routine by now. 8x squareds and 4x squareds make 12x squareds. 5x's and negative 7x's make negative 2x's, and negative 9 and negative 1 make negative 10. Next problem, 2n cubes and a negative n cubed make n to the third. 8n squared plus 2n squared make 10n squareds. An n and a negative 5n combined to negative 4n, and negative 3 and negative 7 is likewise negative 10. So with combining like terms, we get all of the things that are alike together because it's like a common category, okay? A type of thing like an x squared or an n cubed or a number. But once we get to an expression like 12x squared minus 2x minus 10, I can't combine that anymore because this x squared, this first term, that's its own kind of thing, and it's different than an x term in the middle or a number at the end. So they can't be combined. That is simplified. That's a big algebraic word, meaning I've combined everything as best I can. I can't go any further. All right, now let's talk about adding integers. I promised this was coming the other day, and I said this is just like puppy dogs and kittens. So in this first problem, there are 3 positives and you're going to add 2 more positives. So if we just look at the words, and I write the words 3 positives plus 2 positives, that would give me what? 5 positives. Now in math, we put the positive sign in front. We don't put it after. So there's 3 positives and 2 positives. What do you have all together? You have 5 positives. So the answer is 5. We don't bother writing the positive sign as part of the answer. Try the next one, negative 3 plus negative 2. Go ahead. So I have 3 negatives and I have 2 more negatives. So altogether I have 5 negatives. So -3 plus -2 is -5. Next, -7 plus -4. Okay, 7 negatives, 4 negatives. Altogether, if I have 7 puppy dogs and 4 puppy dogs, altogether I have what? 11 puppy dogs. If I have 7 negatives and 4 negatives, altogether I have 11 negatives. Finally, +8 and +1. There's a list of +8s. There's a list of +1. What am I looking at there? I'm looking at 9 positives. So the answer is 9. Now, it's funny how this works, because if I was teaching addition of integers, and I did this is a big reason that impacted how I teach addition now. The first day in years past, before I began to understand this way of presenting the material, I would say to the class, we have 2 rules for adding integers. This is probably how you learned it in class as well. If the signs are the same, you add, keep the same sign. If the signs are different, you subtract, you keep the sign of the bigger number. And I would, whenever I taught integers, I always gave a quiz the very next day, and I would put 10 questions on the quiz. And more than half the class would get 100, probably 3/4. And the ones who didn't get 100, probably sloppy mistakes. They'd get pretty much all 80s and 90s. And the kids were very successful. The next day we would do subtraction and introduce that rule. And the results after that, we wouldn't get anywhere near half the kids getting 100. Probably 1/4 of the kids got 100. And then all of a sudden the grades started to go, instead of 100, 90, and 80, they'd go a few hundred, well, less than half hundreds. A few 90s, a few 80s, but now I'm starting to see 70s and 60s. Then when it came to multiplication, the rule there is like completely different. It's, if the signs are the same, it's positive. And if the signs are different, it's negative. And the kids would take -3 plus -2 and write +5. And -7 and -4 and write +11. Because primary recency effects, they said to themselves, well, if I have negatives and if I multiply negatives, those are the signs are the same, it should be a positive. And that's not true. And this really drove me to trying to explain addition to students so that they would understand it. And I said, guys, I don't care if you're doing integers. I don't care if you're doing puppy dogs and kittens. I don't care if you're doing currency, if you're doing fractions, it's all the same. If I have 3 negatives and 2 more negatives, I have 5 negatives. If I have 7 negatives and 4 negatives, if I'm combining them, and addition is combining, altogether I have 11 negatives. If I have 8 positives and 1 positive, altogether I have 9 positives. So envisioning, understanding what addition is, and this eternal truth that says that you have to have like things, like category, in this case positives with positives or negatives with negatives, in order to combine them. Hence the rule, when the signs are the same, add and keep the same sign. So now we'll see things a little bit different here. -3 and +2, +5 and -2. Try the first one. Let's just see what you come up with. So the great analogy here is chemistry class and electrons and protons, because every time in chemistry a proton and electron come together, they cancel each other out. The net charge is 0. So if I have 3 negatives and 2 positives, there they are, but I can cross out every time a plus and a minus come together because they neutralize each other. 1 positive and 1 negative is a net charge of 0. So in this one, you have -1 as the final answer. How do I know that? Because I look at the diagram. There's only 1 negative left. So the answer has to be -1. Try the next one. Okay. Now, 5 positives, 2 negatives. What happens every time a positive and a negative come together? Cancel each other out because they have a net charge of 0. So I see 3 positives left on the list. This answer is 3. Try the next 2. If it helps you to draw the diagram, do that. And stop and start. Okay, so -7 and 4. There's my the 7 negatives, the 4 positives. Every time they pair up, like the first 4 of these cases, they would cross each other out, and I'm left with a -3. Here's my 3 negatives at the end of the row. +8 and -1. There's a diagram of it. Every time positive and negative come together, they cross each other out. So 7 positives is the correct answer. Hence the rule, if the signs are opposite, subtract and keep the sign of the bigger number. Why keep the sign of the bigger number? Because the bigger number will always have the longer list, right? In the first problem, it was 3 negatives. So the only thing that's left after you cross them out is negatives. Next one, +5 and -2. The 5 will be a longer list because 5 is bigger than 2. So that's why it will always be the sign of the bigger number. Okay, subtracting integers is combining like terms or add the opposite. And I'm sorry here that these did not come out as animations where they fly in. So let me try to correct this here. No, I'm not going to try to correct it because I don't want it to make the slide small, which sometimes funky things happen here. Okay, so first, if I see a subtraction and it's a really simple, straightforward subtraction like I've been doing all my life, I just keep doing it that way. 3 minus 2 is 1. But what if I get 5 minus -2? If I see 2 subtract symbols in a row, or a subtract and a negative, I do circle agregar. That means circle and add. So I circle this, the 2 minuses, and I make it in a plus sign. And it becomes 5 plus 2 is 7. Now, when I look at -7 minus 4, I look at its addition. Everything is addition. I just see what signs you've got. You got 7 negatives and 4 negatives. Altogether, that's 11 negatives. Now, I don't look at the last one in the first row as just addition because I see the minus and negative here. Anytime I see that, I have to add the opposite. So the next one, I look at it as +3 plus -7. If you do +3 plus -7, picture it in your mind. You got 3 positives under the 3. You got 7 negatives under the 7. The first 3 will cancel each other out. There'll be 4 negatives left. -4 is the correct answer. Next, -5 minus a -4. I see the 2 in a row. There's your plus sign. -5 plus 4 is -1. If you take a look, the only problems, this one here, and this one here. The only time you don't just combine them is whenever you see the subtract a negative. Then it becomes make it a positive. And for a gimmicky idea, you just cross the 2 signs to make a plus sign, okay? So how do I interpret -7 minus 3? That I know that I just read it that way, and I know that's what it means, but I interpret it as I'm just going to combine -7 and -3. So if I combine -7 and -3, that's -10, right? I got 7 negatives, I got 3 more negatives. Altogether, that's -10. And this last one, there's the 2 negatives in a row again, make it a positive. +8 and +2 is 10. Now, what about multiplying and dividing integers? In this case, multiplying or dividing by a negative. Think of it as distributing. I want you to think of as if you multiply by a negative number, you're multiplying by the number and then the negative. Now, I know it's not distribution because there's not a parenthesis and a plus or a minus in between, but it still is similar to it. And thinking of it this way is good. So the bottom line is whenever you multiply by, and the by number is the second number, whenever you multiply by a positive, then you just do -5 times 4. If you've got 4 -5s, that's a -5, a -5, a -5, and a -5. That's -20. Okay? So just multiply and keep the same sign. So if you multiply by a positive, there's the 4, it's a positive. Multiply, negative 5 times 4, that's 20, and keep the same sign, negative 20. But if you multiply by a negative, again, the by is the second number, multiply by a negative or divide, then you're going to switch the sign. So negative 5 times 4 is negative 20, but then I'm going to multiply by a negative, so I switch the sign, and that is positive 20. Okay? Try the next two. One's positive, one's negative. Try to figure out which is which. Okay, negative 7 times 3 is negative 21, right? I'm multiplying by a positive, so I keep that sign. I started with a negative, I finish with a negative. Let's look back at the first one. I multiplied by a positive. I started with a negative, I finished with a negative. Let's look at the second one. I multiplied by a negative. So I started with a negative, ended with a positive. Because when you multiply by a negative, you switch that sign. Always switch the sign when you multiply by a negative. The advantage to this way of understanding things is you cannot confuse the multiplication division rule with either the addition or subtraction. Subtraction rule. Okay, negative 7 times negative 3. Negative 7 times 3 would be negative 21, but you have to change the sign because you're multiplying by a negative also. That's 21. What's negative 10 times negative 5? Is it positive 50 or is it negative 50? Well, it's positive 50. Because I multiplied by a negative, I got to change the sign we're starting with. 10 times 5 is 50. Okay, let's see you do the whole last row. Now, before you get started, the rules for division are the same exact rules for multiplication. So, just keep doing what we just did on the previous 5 questions. Okay, negative 12 divided by 4. I'm dividing by a positive, so I keep the sign I started with, negative 3. Negative 12 divided by negative 4. Now I'm dividing by a negative, so I have to switch that sign, positive 3. Negative 3 times negative 3. I'm multiplying by a negative, switch that sign I started with, I get 9. Negative 16 divided by 8. I'm dividing by a positive, keep the sign you started with. And here I'm dividing by negative 2. So that would become positive 1. I don't know why it says 10. It should be 1. Clear. 1. Ding, 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 ding. 1 is the correct answer. I copied these slides over from other slides, and I must have just left the answer there. All right. So now we have some subtraction problems to do, and let's give it a shot. Do the first row of subtraction problems, just the first row. Okay, I was kind of waiting for you to do stop and start, and I forgot all about mentioning it. So, 3 minus 2 is like 3 plus negative 2, right? Or 3 positives, 2 negatives, that's positive. Oh man, where am I at here? Oh no. I did not write the answers in here, so I'm just going to tell them to you. 3 and negative 2 make 1. 5 minus negative 2 makes 7, right? Because circle agar agar. The 2 negatives make that positive there. 5 plus 2 is 7. Negative 7 and negative 4, just combine them, negative 11. And the last one, 8 minus a negative 1 is 9. Let's do the last row now. Okay. Now, three and negative 7 make negative 4. Oh, God. Negative 5 minus a negative 4, so that's circle and add. Negative 5 plus 4 is negative 1. Negative 7 and negative 3 is negative 10. And 8 minus a negative 2 is positive 10. Now, I totally understand that this can be done on a calculator. But when it comes to polynomials and operating like with the double distribute, it helps to be able to do this stuff real quick off the top of your head. So helpful to be able to do that, okay? Last topic of the day, the laws of exponents, okay? There are 3 laws of exponents. The first law says when we're multiplying a base, x to the a times x to the b, I get x to the a plus b. When I'm dividing with the same base, x to the a over x to the b, or x to the a divided by x to the b, I subtract those exponents. It's x to the a minus b. And when I raise a power to a power, x to the a to the b, I get x to the ab. Now, I want to go through answering these questions, and then I want to try to have us understand where these rules are coming from in a way that makes them easier to remember. So here's some examples that show why. If it was x to the third times x to the second, the answer is x to the fifth, because the rule is add the exponents. 3 plus 2 make 5. Why is that so? Because x to the third is xxx, x squared is xx. So what do I see there? I see x times x times x times x times x, which is better known as x to the fifth. In the middle one, x to the fifth over x to the second is going to be x to the third, because the rule says to subtract them. 5 minus 2 is 3. The reason for that is because anytime you have any number divided by itself, it's just 1. So I could take the first x on the top and the first x on the bottom, cross them out, that's 1. The next x on the top, the next x on the bottom, cross those out, it's 1. And all I'm left with is the 3 x's in the numerator, that's x to the third. And then x to the second to the fourth, well, that would be x to the eighth. Why? Because x squared is xx, and if I'm going to raise that to the fourth, I have to do it 4 times, and altogether, that is x to the eighth, right? Because it's 1, 2, 3, 4, 5, 6, 7, 8 x's, all being multiplied. Okay, so let's see you apply the rules for numbers 1 and 2. In fact, only do number 1. Okay, try number 1. So we're going to get x to the ninth. Now on number 2, the rule is to, or the idea is, to multiply coefficients. They're not exponents, so they don't have any special way of dealing with them. Multiply the coefficients, add exponents, okay? So 2 times 4 is 8, x to the 11th. Now the rule for division, similar to multiply exponents, multiply coefficients, add exponents, the rule for division is divide coefficients, subtract exponents. Try numbers 3 and 4. Okay, now, x to the 7th over x to the 3rd, subtract exponents, I get x to the 4th. Here, divide coefficients, 100 divided by 25 is 4, and it's not x squared. Subtract those exponents, it's x to the 5th, 4x to the 5th. Now, try number 5, the rule is to, when you raise to a power, you multiply. So you're going to multiply the exponents, but if you have a coefficient, you're going to do 3 to the 4th. You're going to do whatever it shows you with that coefficient. So try numbers 5 and 6. X to the 3rd is x to the 9th, and 3x to the 3rd to the 4th is going to be 3 to the 4th, which is 81, and then x to the 12th. I don't know why it says 27. 3 to the 4th is 81. It should say 81x to the 12th. Okay, what's the big takeaway here? Look, when dealing with exponents, when you're multiplying, you step it down in operation, you go to addition. When you're dividing, you step it down in operation, you go to subtraction. See, multiplication is repeated addition. So multiplication becomes addition. division is repeated subtraction. So the division becomes subtraction. It's stepping it down a level. And powers is repeated multiplication. So when I raise a power to a power, I multiply. So if I have the same base and I'm multiplying, it becomes addition of the exponents. If I have the same base and I'm dividing, it becomes subtraction of the exponents. In every case, you take a step down in terms of operation. And the last one, when you raise a power to a power, it's multiplication. Okay, let's have you do all 6 of those. Go ahead. Definitely a stop and start situation. Okay, first one. Oh, there's your reinforcers to why the rules work. Number 1, x to the 11th, add the exponents. Number 2, multiply coefficients, add exponents. Negative 8, x to the 13, right? Because 4 and 9 make 13. And we just went over how negative 2 times 4 is negative 8. Multiplying by a positive, keep that sign. Number 3, that's x squared, right? 7 minus 5 is 2. Divide coefficients. I'm dividing by a negative this time, so I have to change the sign. Subtract exponents. Negative 4, x to the 7th. Number 5, x to the 15th, when you raise a power to a power. And now negative 2 to the 5th is negative 32, right? Because it's negative 2 times negative 2 times negative 2 times negative 2 times negative 2. And if you did that in your calculator, you get in the habit of any time you're doing an exponent and you have a negative number, make sure it's in parentheses. Otherwise, half the time you'll get it wrong. Negative 32, x to the 20. Lesson so far summary. Anytime you're going to add or subtract anything in the universe, you have to have the same kind of thing, the same category. It's true for puppies, money, laundry tools, etc. When you multiply by a positive, keep that sign. Multiply by a negative, change the sign you started with. All right, so here is a review of several of the topics we've been doing so far. And by the way, I should mention, today introduced these topics to you. Just like this is now the 4th lesson, and you've seen questions like this on every homework, and now within every lesson, it'll be the same for the newer material. So you don't have to understand everything perfectly today. My hope is that you understand it perfectly in 3 or 4 lessons. Go ahead. Answer all of these, stop and start, and then I'll show you the correct answers. Okay, using clock math, 8 plus 7. Remember, clock math is the remainder upon division by 12. 8 plus 7 is 3, right? Because it adds up to 15 divided by 12, 3 is left over. 9 minus 11 is actually going to work out to be 10. Think of it this way, if you did 9 minus 12, it would be back to 9. So if you only went backwards 11 places, well, that means that you have to end up 1 place before the 9. It takes all 12 places to get back to the 9. 8 times 4 is 32. If I divide 12 into 32, the remainder is 8, right? 12 times 2 is 24. All right. Using the factor of €1 is $1.09. See if your work matches. You must get it into a common currency so that you can add them. When the currencies are different, you can never combine them or add them. Explain why adding fractions or what it has in common with adding puppies and kittens. In order to add anything, whether it's fractions or puppies, you have to have a common category, a common type. So with fractions, you could have ninths and ninths. You can add those. You cannot add ninths and fifths directly. You have to then get a common category, and that's where the 45 would come into play. With puppies and kittens, you can add puppies to puppies. You can add kittens to kittens, but you can't add puppies and kittens at the same time unless you broaden it out and you just call them pets. Simplifying by combining like terms, 5x squared and negative 1x squared is 4x squared. 11x's and negative 9x's is 2x's. See how I'm doing this? I'm not even looking at it as subtraction. I'm just combining everything, just like the rules for subtraction, and I just look at the sign in front. Negative 4 and positive 9 makes positive 5. Part 2. Go ahead. All right, let's see how you did here, because you, of course, did stop and start. 3x squared and a negative x squared is 2x squared. 10x and negative 9x make 1x. Negative 4 and negative 5 make negative 9. Three sides of a triangle measure 7 feet, 5 yards, 108 inches. Find the perimeter. Well, we need a common unit to do that. And I think feet are probably best. 5 yards would be, each yard is 3 feet. So 5 times 3 feet is 15 feet. 108 inches. Well, there's 12 inches in a foot. So 108 divided by 12 gives me 9 feet. And then we also started with 7 feet. So if we add them up, 15 feet plus 9 feet plus 7 feet, that is altogether 31 feet. Okay. So that's the end of our slideshow. Enjoy. Don't forget to get that homework done. Next week, assessments start.